3. Go, nigga.
Hello everyone. Today I'm going to explain the correlation between kinetic energy and work done over an object. So we know. So first of all, what is work? People say do that. What is work? Like, guys, come on now. So we all know that work in physics is defined as the force needed to push an object from point A to point B. So let's say you have a body mass, right? It's moving on a surface, and this is position x, I, and this is position x final. So this body, it originally has a initial velocity, right? And let's say you push it to increase its velocity. We all know that if you push something, obviously it's gonna move faster. So if this mass reaches here with a final velocity, we all know that there is obviously change in energy between initial position to final position. So what is the definition of work in terms of formula? So work is defined as the force needed to push this mass from here to here times the dot product change in displacement. So change in displacement is usually xf minus xi. Change in x is equal to xf minus xi. Alright, so as we all seen, we already know that work is equal to f dot dx. So we're gonna keep this. You understand? We're gonna just keep that. So according to the laws of kinematics, we know that if an object is moving in x direction, this is an object, our mass, it moves from here to here. It has an initial position and it has a final position, and it moves a certain distance. So this distance is change of x. And this mass too had an initial velocity, and it also has a final velocity. And we know that there was a force that acted on this body to move it from here to here. Do you understand? So now, according to the laws of kinematics, we know that there is a formula that relates final velocity, initial velocity, acceleration, and the displacement. So this is the formula I'm going to show you. So the formula states F final squared is equal to F initial squared plus 2A, which is acceleration, and S. But what is this S? This S can literally be F final squared is equal to 2A. S is the change in displacement, which is d of x. You know what I'm saying? So let's keep this formula as 1. So, and we all know, as we are trying to find the force done on this object, we can literally replace acceleration with force. So how are we going to do that? We know that according to Newton's second law of motion, the force of an object is directly proportional to its mass and acceleration. Do you know what I'm saying? So acceleration is what we're trying to find. But we know that force, according to Newton's second law of motion, is equal to force times acceleration. So acceleration is equal to force over mass. So now, so we do 2 in 1. Equation 2 in 1. So if we're putting this acceleration in our function, we're gonna get v final squared is equal to v initial squared plus 2 force over mass change in what? Change in displacement. This is theory. So now that we're here, all we need to do is find this kind of reference. I don't want to, cheat sheet. I don't want to show the grand prize, so I don't want to spoil the fun, if you know what I'm saying. So yeah, so how are we gonna find that equation? So we multiply both sides by m. So it becomes v final squared over, sorry. Okay, maybe get this. Alright, so So it's we multiply both sides by m. So it becomes m vf squared is equal to m v initial squared plus 2f dx 4. And then in our equation 4, we multiply both sides with 1 over 2. So it becomes 1 over 2 mvf squared is equal to 1 over 2 mv initial squared plus f dx. This is our equation 5. So from equation 5, we can see that we already have this reference, and that's why I kept this this function over here. We all know that force is equal to work is equal to force dot product of change of displacement, and this is this, and this turns into what? This turns into work. So work is equal to this 1 over 2 mv final squared minus this comes here 1 over 2 mv initial squared. And from what you can see, we all know that the kinetic energy of an object is equal to, this is the formula, 1 over 2 mv squared. So this is the final kinetic energy. This is the initial kinetic energy. So as you can see, we can literally find a definition of work using the kinetic energy, which is equal to, work is equal to change in kinetic energy. So what does that tell us? That literally tells us our work will be both in joules, because it's energy, and it's gonna be equal to the the final kinetic energy that our mass have, because it has the Ke final and Ke initial. It's gonna be the difference between the final kinetic energy and the initial kinetic energy. It will be our work done on this specific object. Thank you.